everyone, how are you all? We have come to the last topic of the chapter. Yes, in the previous video we have discussed about the redox reactions, is it? And now is the continuation of redox reaction itself. I am dealing with the most important type of a question. These types of the question can come for MCQs or 1 mark. If you can watch the video carefully and if you can understand this video, you can easily solve those questions which can come under MCQ part or 1 mark. Okay, very easy type of the question. You just need to observe and analyze carefully here. Okay, so let us go to the topic. And before going into the questions, let us try to recall what were the redox reactions. So what do you mean by a redox reaction? The name itself says RED, red, in the sense reduction. Okay, so RED stands for reduction and OX stands for oxidation. Yes. So what do you mean by this redox reaction? It is such a reaction in which we can observe both oxidation and reduction at a time. Okay, actually most of the chemical reactions that are happening inside our body are redox reactions only. The oxidation of glucose, in the process of digestion, many reactions would occur, right? Hundreds of chemical reactions that will take place inside a human body every day. All these reactions, say 95% of these reactions are redox reactions only. That means in a single step, both reduction is also happening, oxidation is also happening. Okay, so such reactions we will call them as redox reaction. And now let us try to recall the meaning of reduction. So what do you mean by reduction? Addition of hydrogen, yes, addition of hydrogen or removal of oxygen is called reduction. Okay, addition of hydrogen as well as removal of oxygen is called as reduction. It has two meanings. First meaning is addition of hydrogen. Another meaning is removal of oxygen. Anything that you can observe among these two meanings, it is considered to be the reduction reaction. Okay. And now what is the meaning of oxidation? Say in shortcut, I will write OX for oxidation and I will write RED for reduction. Okay. So meaning of oxidation is opposite to reduction. That means addition of oxygen or removal of hydrogen. Removal of hydrogen is called oxidation. Okay, so you must get perfect with these meanings. Once you can become perfect with these meanings, rest of the work is very simple. You just have to look and analyze a chemical reaction and decide the answer. So before analyzing and understanding a chemical reaction, definitely you must know the meanings of what is reduction and what is oxidation. Clear? Fine. And now I have listed few redox reactions here. Now you all know redox in the sense you will observe both oxidation process as well as reduction process. Is it? Okay. Now coming to the first reaction. Observe the first reaction. You see copper oxide plus hydrogen. These are our reactants. Okay. They are reacting and what you are getting here? Copper and water. Okay. So first let us identify whether it is a redox reaction or not. Okay. To identify whether it is a redox reaction or not, you should observe the reaction very carefully. Okay. Just check it out. Your copper oxide is there. Okay. One of the reactant is copper oxide. And how this copper oxide has converted? To what element it has been converted into or to which chemical compound it has converted into, you have to observe. Okay. See, our copper oxide, search in here is copper, right? So our copper oxide is converted into simple copper. So in this conversion, what is the observation that you can do? You can observe the removal of oxygen, is it? Yes. Observe this conversion carefully. Copper oxide is getting converted into copper. Okay. How it is getting converted into copper? With the removal of oxygen, is it? So removal of oxygen means what? Removal of oxygen means reduction, is it? So this means reduction. So this process, this conversion is nothing but reduction reaction, because you have observed the removal of oxygen atom. Okay, so this is how you have to analyze a reaction carefully. Okay, now coming to the next reactant. Next reactant, our hydrogen. So this hydrogen has converted into water, is it? Yes, you just have to search like this. Say hydrogen is there. In the product, where is our hydrogen? Where it is present and how it is present, you have to search. So your hydrogen has converted into water. So observe this process. What is the observation that you can do? How did our hydrogen converted into water? By the addition of oxygen, no? You see, what is the difference between the reactant and product here? Oxygen. Okay, oxygen has been added, so water is forming here. So what is the process you are observing here? Addition of oxygen. Addition of oxygen is nothing but oxidation. Yes, the meaning of addition of oxygen means it is oxidation reaction. So this conversion is oxidation, right? So this is one full chemical reaction, but here you can observe reduction process also, and you can observe the oxidation process also. So that is why this reaction is called redox reaction. Okay, so now the type of question that can be asked on this redox reaction is, listen carefully, they will give you an equation like this. They won't mention this. They won't mention this process is oxidation and this process is reduction. Just they will give you one chemical equation and they will ask you which is oxidized and reduced. Okay, among the reactants, which is oxidized and which is reduced, they will ask you. Okay, so which is oxidized means the reactant that underwent oxidation you have to mention, and which is reduced means the reactant which underwent reduction you have to mention. Okay, so they will give you a chemical equation like this and they would ask you a question like this. Okay, so now let us work out with the second example. Okay, before going to the second example, let us try to write the answer for this question for the first equation. Okay, for the first equation, already we have recognized which is a reduction and which is a oxidation. Now you have to write answer for the question if they ask like this, giving this equation. Okay, fine. And now here, which is oxidized and which is reduced? See, you have to concentrate only the reactants only. Among the reactants only, one reactant will undergo reduction and one reactant will undergo oxidation, no? Right? So that is what you have to mention. See, copper oxide underwent reduction, is it? So we will write copper oxide is reduced. Okay, which is reduced here? Copper oxide is reduced, we will say. The one which undergoes reduction can be called as reduced. Okay, The one which underwent oxidation. Who underwent oxidation? H2 underwent oxidation. So we will write H2 is oxidized. H2 is oxidized. Okay. So this is our answer. If they give this equation and if they ask you which is oxidized and which is reduced, your answer is copper oxide is reduced, hydrogen is oxidized. Okay, clear everybody? Concept should be perfectly understood. Then only you can understand what question they have asked and how you have to write the answer. Clear? Okay. So now the same question, if I ask for a second equation, then what is your answer? Let us work it out. So before you give answer like this, first you have to identify which conversion is reduction and which conversion is oxidation. Is it? Okay. Now let us work it out. See, ZnO, okay, zinc oxide, it is getting converted into zinc now. Okay, where is the zinc containing product that you have to search? Because the reactant is zinc containing product. Reactant. Okay, so here zinc oxide is converted into zinc. So what process you are observing here? Oxidation or reduction? See, oxygen was there in a reactant, product it is not there. Yes, you can observe only zinc here. That means removal of oxygen took place now. So what is this process called? Removal of oxygen is called as reduction. Yes, so both the meanings you should remember for reduction as well as oxidation. So here we can clearly observe which process it is. Removal of oxygen is called reduction. Okay, similarly coming to the next reactant, carbon. Carbon has converted into carbon monoxide. Is it? So oxygen has been added now in this process. See, carbon single, but in the product it is there as carbon monoxide. See, addition of oxygen took place here. Addition of oxygen is called what? Addition of oxygen is called oxidation. So this conversion is oxidation. So first you have to analyze what process the reactants are undergoing. Okay. After that you write the answer. Okay. So now the question for this equation is which is oxidized and which is reduced. Now tell me which is reduced. Which one underwent reduction? ZnO underwent reduction now. So ZnO is reduced. And which one underwent oxidation? Carbon underwent oxidation now. So carbon is oxidized. This way you have to write. Okay. So instead of writing ZnO underwent reduction, carbon underwent oxidation, we are writing like this. ZnO is reduced, carbon is oxidized. The meaning is ZnO is undergoing reduction and carbon is undergoing oxidation. This is what the meanings of this word reduced and oxidized. Okay, fine. So similarly, can you be able to decide your answer for this equation? Same way, I have given this equation and I am asking you which is oxidized and which is reduced. Just check it out. Among the two reactants, which one is undergoing reduction? That is reduced. Which one is undergoing oxidation? That is oxidized. Yes? Let us work it out. See, MnO2 has converted into what product here? MnO2 is converted into MnCl2. Is it? Mn containing substance is this only. So MnO2 is converted into MnCl2. So which process it is? Oxidation or reduction? Here oxygen was there previously, but here oxygen is not there. That means removal of oxygen took place. Removal of oxygen is called as reduction. So MnO2 underwent reduction here. Then definitely HCl will undergo oxidation, no? So among the two reactants, if one is undergoing reduction, definitely another one will undergo oxidation only, because it is a redox reaction. That means you should have both reduction as well as oxidation process. No. So logically speaking, use little much common sense here. If this guy is undergoing reduction, definitely the other reactant must undergo oxidation. No. So that is the logic here. So here your HCl is getting converted into Cl2. So what you have observed here, H was there previously. Now here no H. That means removal of hydrogen took place. Now removal of hydrogen's meaning is what? Oxidation. Okay. So this is how you have to write initially, and now you write your answer, which is reduced. Which one underwent reduction? MnO2. So your answer is MnO2 is reduced. And what is the answer for second category? Which is oxidized? Which is oxidized? HCl. HCl is oxidized. Okay. So in your answer, you are not supposed to mention anything from the products. You have to decide between the reactants only. If one is reduced, the other one will be definitely oxidized. Okay. Among the reactants only you have to select the answer. With respect to the reactants, you have to write the answer. Clear everybody? So you have to work with the examples, then you will become perfect. Okay. And now, the question, this is the question I have. Copy the question carefully and you are going to tell me whether sodium is oxidized or reduced. Okay. Try to understand the question carefully. You have a question and I am asking what happened for sodium. Is it oxidized or reduced? Whether sodium is oxidized or reduced. Okay. And write your answer in a comment section. Post your answer in a comment section. I will be waiting it. Okay. Clear. So that was the question for you. You have to work it on. Pause the video. First work it on. Write the answer in the comment section and look at the further video. Clear? Next, let us discuss something about the corrosion process as well as rancidity process. Coming to corrosion. So what do you mean by a corrosion? Okay, say for example you have iron articles, newly brought iron articles, and iron table or iron chair, whatever it is, it has not painted it, pure iron, okay, you have with it, brought it from a market. And you kept that iron chair or iron table outside, not inside the house, outside you kept for so many days. You know, it has been kept raining and hot sun was there. Some days were sunny, some days were rainy, right? Some days were humid. You know, it is getting exposed to the atmosphere for a longer time. See, after 2 months or 3 months, okay, you go and check the iron chair. What you would observe? You have a same feeling of iron that you brought it in a day one. Do you find any change between the day one and now? Definitely, right? You would definitely find that brown color powder that has appeared on an iron chair. Its quality got decreased. There is no quality for the iron chair. Yes, it might have lost its shine also. And you would observe especially this brown color powder that has been appeared on a chair. Yes. And what do you say in a normal word? You would say iron chair got destroyed. Yes or no? Iron chair spoiled, destroyed, quality decreased. Why that quality decreased for the iron chair? Because you kept it outside for a longer time. You did not care that iron chair. You have exposed to the atmosphere. So, it has been spoiled. Okay. So, what would have happened for the iron chair when you kept it outside? Why did it get spoiled? Can you give me a reason? Why did that iron chair got spoiled when you kept it outside for a longer time? Why did you observe that brown color powdery thing on an iron chair? The reason is corrosion might have happened. So what do you mean by a corrosion? Certain metals like iron, okay, it is quickly reacting with moisture in the atmosphere, or oxygen content in the atmosphere. Okay, say for example iron. Okay, when you kept it outside, it would have reacted with water and it would have reacted with oxygen. Water in the sense, you will have water vapor in the atmosphere, yes or no? Definitely. So, after reacting with these two guys, this iron would have become Fe2O3.2H2O. Okay, so this is the substance that might have created, and this is what we will call it as rust in a normal language. Okay, that powdery, brown color powdery substances that you can observe on an iron chair when you keep it outside, no, that is called as rust. Okay, rust is nothing but this chemical compound. Okay, now iron has been converted into something else. It is no more a iron. It is no more a pure Fe. Your Fe has converted into Fe2O3 into .2H2O. Yes or no? So this process only we will call it as rusting of iron. Rusting of iron in a normal language. Okay, and rusting can also be called as corrosion. In a chemical language, rusting, that is spoiling of a metal, can be called as a corrosion. When is this metal is getting spoiled? When it is reacting with atmospheric oxygen or water or any other compound present in the atmosphere. Iron is reacting with these two substances. Another metal may react with another substance present in the atmosphere. That way the metals will get spoiled. The metals will get destroyed. Okay? And such a destruction of metals, when you expose them to the atmosphere, is called as corrosion. Okay, so rusting of iron is one example for corrosion. Okay, so this is first example that you have to remember. Now second example I am giving you. Silver articles become black. Yes or no? Silver articles become black. They lose their shine. Say for example, silver earrings or silver anklets we will wear. Yes or no? And day one, the day you purchase the silver articles, it will have a nice shine and very smooth also. Yes, that silvery shine would be there. But after 100 days, after few days, will the shine be there after 100 days also? No, right? So what would happen? Slowly the silver articles would turn blackish. Yes or no? So why they turn blackish? It is because the silver is reacting with the oxygen present in the atmosphere. Yes? In the day one, your silver is pure. As the days goes on, the silver is getting exposed to atmosphere. Atmosphere contains oxygen, yeah? And your silver is becoming Ag2O. Silver oxide. Okay, this silver oxide is what? Black in color. Okay, imagine I am wearing a silver bangle. Okay, so as the days goes on, every day I go out, I will get exposed to the atmosphere, right? We can't stay inside the house in a dark room. We will go to the atmosphere. So this particular silver bangle will react with oxygen. So slowly silver oxide will be secreted. Its layer would be formed. So that is what? The black color. Silver oxide is black color. That is why silver articles become black as the days goes on when you get exposed to oxygen. Okay, and this is another example for corrosion. Okay, corrosion in the sense any metal that is getting spoiled, its quality is getting changed because it is exposed to atmosphere, because it is reacting with the chemical compounds present in the atmosphere. That is corrosion. And the third example that you have to remember is copper articles become green. Yes or no? Copper articles, you know the color of copper, shiny brown color it will have. So the copper also, many days when you keep it outside, slowly that green color coating you will appear. It will become greenish. Yes or no? That is because your copper is actually reacting with the carbon dioxide present in the atmosphere. And it would become copper carbonate, and this copper carbonate is green in color. Slowly your pure copper is reacting with carbon dioxide, and whichever copper is reacting with the carbon dioxide, that is becoming copper carbonate, and copper carbonate is green color. That is how you are observing that green coat on a copper. Here everyone? So these are the 3 examples of corrosion you have to remember. Definition of corrosion is important, and the 3 examples are also very important. Coming to the last topic of the chapter, rancidity. Okay. So before we go for the meaning of rancidity, let me ask you a question. Imagine you have got the chips or biscuit packets from the bakery. Okay. The moment you open the chips packet, you know, the chips will be very much fresh. They taste very greatly. And imagine you have some more chips left in a packet and you kept it open for 2 or 3 days. Okay. And after 2 or 3 days, you are observing the chips. And how will the chips look like? Will it be fresh? Will it be tasty as that you can observe on day 1? No, right? It will lose its taste. And you get a kind of smell also. Little bad smell you will get. And chips will become, very soft. They won't be crispy, isn't it? So what has happened to the chips? The moment you open the packet and kept it for about a day or 2, their smell and taste have become changed. Yes or no? But in the bakeries, as long as the packet is closed, for days together, for months together, they remain very much fresh inside the packet. But the moment you open the packet, you keep for about 1 day, their smell and taste is getting changed. So what is the reason for change of smell and taste? It is because the fats and oils which were present in the chips. Definitely chips contain oil and some fat. And these fats and oils, when they get exposed to the atmosphere, they will react with the oxygen. Okay, they will react with the oxygen and they will be converted into something else. They won't remain as fat and oil now. They are converted into some other chemical substances. So their smell and taste will be changed. And this process only we will call it as rancidity. So what is rancidity? Fats and oils. Fats and oils. Okay, react with oxygen of atmosphere leading to the change in their taste and smell. Okay, this process only we will call it as rancidity. Okay, so whenever fat containing foods or oil containing foods, when you keep it to atmosphere, they would react with oxygen so that they would be converted into something else and their taste and smell can be changed, and this spoilage of food we will call it as rancidity. Okay, and now how do you prevent rancidity? Very important question for board examination point of view and very simple also. So how do you prevent rancidity? The first way of preventing rancidity is keeping food in airtight containers. Okay, so air should not pass in a container where food is there. Air contains oxygen. No, if air passes, definitely the fat and oil may react with oxygen and they will get spoiled. So that is the reason you should always keep the food items which contain oil and fat in a airtight container. Okay, so the first way of preventing is keeping food in airtight containers. Okay, which type of food? The food that contains fat and oils. Okay, so that is the reason pickles and all we will keep it in airtight containers. We don't get exposed into atmosphere because pickles contain a lot of oil and fat, no? So if you keep it open, what would happen? It would react with oxygen and its smell and taste will change quickly. It will get spoiled. That is why at the home our mothers would be telling keep the pickles in an airtight container. Close the lid properly, they will say, right? It is because to prevent the rancidity of food items. Clear? So keeping the food in airtight container is one way to prepare, and the second one is by flushing with antioxidants. Antioxidants, very important word, try to remember. The example for antioxidant is nitrogen. Okay, so antioxidants are those chemical substances that will prevent the oxidation of fat and oils. Okay, reaction with oxygen is called oxidation, no? So antioxidants are those chemicals that will protect fats and oils from reaction with oxygen. Okay, so antioxidants do not allow fats and oils to react with oxygen. So what you have to do, these chips packets and all, before they pack, they will flush with the nitrogen gas, because in case if any air goes in also, these antioxidants will protect the fats and oils. They will not allow the food items, the fat and oil, to react with oxygen. Okay, they will be protecting them. They will not allow the reaction to happen. Such a chemical substances are called antioxidants, and the best example is nitrogen gas. So question can be asked like this: why do the chips packets are flushed with a nitrogen before packing? The answer is to prevent rancidity. Antioxidants will not allow fat and oil to react with oxygen. Okay, so this completes our chapter. So revise every concept carefully and try to read the textbook. Read line by line in a textbook, and that is very important. Thank you so much.